Chapter 6 Application of Derivatives, Exercise 6.3 or 6.5 in the previous textbook, 26th question. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is sin inverse 1 by 3. So I have shown a cone here. So let R be the radius of the base of the cone. Now we have the h, that is means the height of the cone. L be the slant height of the cone. Now we have V as the volume of the cone, that is equal to 1 by 3 pi r square h. Now S is equal to the surface area of cone, which is equal to pi r square plus pi r l. Now from the figure of cone we have L, H and R. So it's a right angle triangle. So applying the Pythagoras theorem here, we have L square is equal to H square plus R square, or L is equal to root of H square plus R square. So surface area of the cone S is given by pi r square plus pi r l. Instead of L we have H square plus R, root of H square plus R square. Substituting that, so we can write taking pi r square in with S, we have pi r into root of H square plus R square is equal to S minus pi r square. Pi r square is taken to the right side, or dividing by pi r on both sides. So we have pi r into root of H square plus R square by pi r is equal to S by pi r minus pi r square by pi r. So cancelling the terms of pi r's, we have root of H square plus R square is equal to S by pi r minus r. Now squaring on both sides, so we can write root of H square plus R square whole square is equal to S by pi r minus r whole square, or H square, root and square cancel, so H square plus R square is equal to S. By expanding the terms, so we have S square by pi square R square minus 2 R by pi r plus R square cancel, so we have H square is equal to S square by pi square R square minus 2s R and R cancel, so 2s by pi. Now we have H is equal to root of that is A square by pi square R square minus 2s by pi. Now what is volume? Volume is equal to 1 by 3 pi r square h. So V square is maximum and V is maximum. So what is V square? That is 1 by 3 pi r square h whole square, that is 1 by 9 pi square r raised to 4 h square. So instead of h square we have the equation for h, right? So substituting that here, so pi square r raised to 4 by 9 into root of h square pi square r square minus s 2s by pi whole square, root square cancelled. So pi square r raised to 4 by 9 into a square by pi square r square minus 2s by pi. Now opening the bracket, we have pi square r raised to 4 into a square by 9 pi square r square minus pi square r raised to 4 into 2s by 9 pi, cancelling the terms. So we have the remaining, that is s square r square by 9 minus the next term, that is 2s pi r raised to 4 by 9. So that is V square. Now we are finding what is d by dr of V square, that is d by dr of the given terms, that is s square r square by 9 minus 2 pi s r raised to 4 by 9. Now first d by dr of s square r square by 9, s square by 9 is a constant, into r d by dr of r square, that is 2r, minus 2 pi s by 9 is again constant, into r raised to 4, that is 4r cube d by dr. So we have 2s square r by 9 minus 8 pi s r cube by 9, that is d by dr of v square. When d by dr of v square is equal to 0, we can write 2s square r by 9 minus 8 pi s r cube by 9 is equal to 0, or we have 2s square r by 9 is equal to minus 8 pi s r cube by 9 is taken to right side, is equal to 8 pi s r cube by 9. So cancelling the terms, 9, 9, 2, 8, remaining 4 is s square, etc. So we have the remaining, that is r square, r cube r, that is r square is equal to s by 4 pi. So we have got what is r square. So what is r? Then it is root of s by 4 pi. Now we are finding the second derivative, that is d square dr square of v square, that is d by dr of 2s square r by 9 minus 8 pi s r cube by 9. So we have d square r dr square of v square is equal to, first term d by dr of 2s square r by 9, that is 2s square by 9 only, minus d by dr of 8 pi s r cube by 9, that is 8 pi s by 9 is constant, into r cube d by dr, that is 3r square, or we can write 2s square by 9 minus 8 into 3, that is 24 pi s r square by 9, that is d square v square d by dr square. When r is equal to root of s by 4 pi, we are applying it in the equation of d square v square by dr square, that is 2s square by 9 minus 24 pi s by 9 into, instead of r square, that is s by 4 pi. R is equal to root s by 4 pi. So r square is equal to s by 4 pi. Cancelling 24 and 4 in the second term. So we have the remaining, that is 2s square by 9 minus 6x square by 9. So we have d square v by v square by dr square is equal to 2s square minus 6x square, that is minus 4x square by 9. 9 is the common denominator. So minus 4s square by 9, that is a negative quantity which is less than 0. So we have maximum here. So we have got maximum here at r is equal to s root of s by 4 pi. So now we will be going back to our question, that is for a semi-vertical angle, it is given that in the question for a semi-vertical angle with of a right circular cone of given surface area and maximum volume is sin inverse 1 by 3. So we have got surface area and maximum volume here. So we want to find the semi-vertical angle is equal to sin inverse 1 by 3. So we have for that, what is h first? That is we have got h is equal to root of s square by pi square r square minus 2s by pi, or from this h square is equal to s square by pi square r square minus 2s by pi. So we have got what is h square. Now what is r? That is root of s by 4 pi. So r square is equal to s by 4 pi. So we have h square and r square. Now we have the equation for h square, that is s square by pi square. R square is s by 4 pi minus 2s by pi. Substituting the value of r here. So we have h square is equal to, cancelling the terms s square s and pi square pi, we have 4s by pi minus 2s by pi. What is 4s minus 2s? That is 2s itself. So h square is equal to 2s by pi. So we have got h, r, etc. So we will be having the Pythagoras theorem, that is L square is equal to h square plus r square. From this L can be find out. So L square is equal to 2s by pi minus what is r square, that is s by 4 pi, or cross multiplying we have 2s into 4 pi, that is 8s pi minus pi into s, that is s by 8 by 4 pi square. 8s pi pi plus s pi pi, that is 9s pi divided by 4 pi square. Cancelling pi square and pi, we have L square is equal to 9s by 4 pi, or L is equal to root of 9s by 4 pi. 9 and 4, their root are 3 and 2, right? 3 by 2 root of s by pi. So we have got L, h and r. So we have the semi-vertical angle, let it be a theta. I have marked in the figure. So what is the sign of theta? That is opposite side by hypotenuse. So we have for an angle theta, sin theta is equal to opposite side by hypotenuse, that is sin theta is equal to, from the figure it is opposite side is r and hypotenuse is L. So r by L. So we have the values for r and L. That are the r, that is s by root of s by 4 pi, and L is equal to 3 by 2 root s by pi. Substituting that, so we have root of s by 4 pi divided by root of 3 by 2 s by 4 pi, or root of 9 by 4 s by pi, both are equal. So cancelling the terms, we had 4 pi root 4 pi root 4 pi, and so we have root s by root 9s. Again cancelling root s, we have 1 by root 9. What is 1 by root 9? That is 1 by 3. So we have got sin theta is equal to 1 by 3, or theta is equal to sin inverse 1 by 3. So for a given surface area and volume of a right circular cone is maximum when theta, the angular when the semi-vertical angular theta is equal to sin inverse 1 by 3. Hence proved.